So we're going to do Newton's third law now. So for every action, there's an equal and opposite reaction. So take a look at this book on the table. The book is being pulled down to earth. We know that because it's not floating around, right? So that's gravity pushing down. But we also may not realize the table's pushing back on the book. And we know that because the book is not being pulled through the table. Think about it. What happens if you're standing on a skateboard or a slippery floor and you push against the wall? You slide in the opposite direction away from the wall because you are pushed. You pushed on the wall, but the wall pushed back on you with equal and opposite force. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe is going to be hurting. A bug with a mass of 5 grams flies into your windshield of a moving bus of 1,000 kilograms. Which will have the most force? The bug on the bus or the bus on the bug? Well, the force would be the same because the force of the bug would be a small mass times a big acceleration, and the force of the bus would be a big mass times a small acceleration. So action and reaction on different masses. Consider you and the earth. Your action force is that the earth pulls on you. The reaction force is you pull on the earth. The action force is that the tires push on the road when the bus is driving. The reaction force is that the road pushes on the tires. And the evidence of this is you can see as tires get older the wear and tear on the tires. So the action force here, the rocket pushes on the gases. The reaction force is the gases push on the rocket, propelling it into space. Consider hitting a baseball with a bat. If we call the force applied to the ball by the bat the action force, which one of these would be the reaction force? So remember, the force applied to the ball by the bat is the action force. So the reaction force would be the force applied to the bat by the ball. So suppose you are taking a spacewalk near the space shuttle and your safety line breaks. How would you get back to the shuttle? The thing to do would be to take one of the tools from your tool belt and throw it as hard as you can directly away from the shuttle. Then, with the help of Newton's second law and third law, you would accelerate back towards the shuttle. As you throw the tool, you push against it, causing it to accelerate. At the same time, Newton's third law, the tool is pushing back against you and in the opposite direction, which causes you to accelerate backwards towards the shuttle as you want. What laws are represented here? So what laws are represented here? So you probably see the conservation of momentum. So originally the car is stopped, but the truck is transferring momentum to it and it starts moving. You probably see Newton's first law. The ladder is in motion and continues to be in motion because there's nothing there to stop it. You probably see the third law. For every action, there's an equal and opposite reaction. You probably see Newton's second law. The truck is more massive. There's bound to be more damage to the little car than the big car. Okay, so we're going to review all 3 laws. They're going to be on your quiz this time. So Newton's first law, objects in motion tend to stay in motion, objects at rest tend to stay at rest, unless an unbalanced force acts upon it. Newton's second law, force equals mass times acceleration and all those parts of it. And Newton's third law, for every action there's an equal and opposite reaction. So let's talk about Homer there. So Newton's first law, Homer is large and has much mass, therefore he has much inertia. Friction and gravity oppose his motion. Newton's second law, Homer has mass times 9.8 meters per second, which equals his weight, which is a force. And Newton's third law, Homer pushes against the ground and it pushes back.